Thank you. All right, it's the last session of the day. A lot of talks going on. I'm sure everyone's information overload, so I'm gonna go through this at a good speed, not overload everyone more. Thanks for everyone to join at the last session. So what am I gonna walk through? I'm gonna walk through the journey that the product I work on called IBM Spectrum Conductor has gone through of using Spark, and how we've had to change it over the years to plug in our work and the enhancements we've done to it. It's been a bit of work, constantly changing, not being in the open, so we want to make it easier for us and others out there to plug in additional schedulers. So after I go through the journey, I'm going to talk about the proposal. First, just a little bit about me. I'm the lead architect of IBM Spectrum Conductor, and I'll talk about that a bit more after this slide. I've been working on distributed computing, grid, cloud, and big data for the past 5 years. I've focused on the entire life cycle, but I've done development across every aspect of that, starting from the user interface to make it as simple for users as possible, to working on the application lifecycle management, the scheduling in the resource orchestrator that we use, and even making changes into Spark. So I work with a lot of customers now, but I always make sure to go back to my roots of development. So what's IBM Spectrum Conductor, and why do we make changes to Spark? So I'm going to read the marketing blurb, and then I'm going to break it down more. So IBM Spectrum Conductor deploys modern computing frameworks and services for a multi-tenant enterprise environment, both on-premise and in the cloud, with a focus on Apache Spark. So what does that really mean? So inside IBM Spectrum Conductor, we have our own resource orchestrator. We don't use Yarn, we don't use Mesos. So you might be thinking, oh great, why another one? Well, we use what we call Enterprise Grid Orchestrator, or EGO. And it's been around for 30+ years. It started being used for HPC workloads and has continued on from there to even do Spark workloads now. So it's been proven at scale at the largest companies in the world, and it's been around for 30 years. So we make sure it can really scale. It's the fastest and secure. So with it, we can deploy on-prem, which is what everyone did 30 years ago. We can also deploy in the cloud for anyone that's trying to do new workloads and using the cloud now for everything. Or we can do a combination of the two. So we can deploy on-prem and burst into the cloud when you need more resources. So in the beginning, IBM Spectrum Conductor actually wasn't called IBM Spectrum Conductor. It was called IBM Platform Application Service Controller. And what it could do is it could deploy any modern computing framework out there, including Spark. We didn't focus on Spark, so you could just go and deploy Spark, go and deploy Mongo, Cassandra, Hadoop, anything you really wanted. And then we saw Spark taking off. And we thought, OK, we should really integrate with Spark and make Spark the big glue of this, but still support all these other frameworks out there, because we're using them in conjunction with Spark still. So as we were doing that, we decided to introduce a concept called Spark instance groups, or just instance groups, to provide multi-tenancy. With those, we would deploy your modern computing frameworks, like Spark, Anaconda, and any services with it, efficiently, effectively, and supporting multiple versions. So in one cluster, you could deploy Spark 2.4.1, and 1.6.1 if you really had old applications running, or anything in between. And with these, you could easily stop and start them, and even take them down for a while if you needed to, start them up when you needed to rerun those old legacy Spark apps on 1.6.1, or just keep them running all the time. So with this, we were able to increase performance and scale through granular and dynamic resource allocation for instance groups using the shared resource pool. So instead of having every application out there having their own dedicated silo of hosts, we brought that all together, and using our Enterprise Grid Orchestrator and concepts of resource plans inside of it to effectively give each of those frameworks the resources they need when they need it, and making sure that we're optimizing the hardware that we have. So now that we know about IBM Spectrum Conductor, a little bit at a high level, let's talk about the journey that we went through when we started to integrate Spark as a core piece of our technology. So as we went about it, we didn't want to just run Spark standalone inside our cluster. We wanted to really take advantage of Ego in there. So what we started to do was, just like we have for Yarn and Mesos, we started to write another cluster manager inside of Spark to handle working with Ego. But because we're not open source, we couldn't put it out in the open. We had to keep it closed source. You don't want another cluster manager out there that can't really be used unless you buy a whole other product. So with this, we started modifying a whole bunch of files, copying some, and just extending some. And then we started to do more enhancements in Spark, adding additional features like GPU support, being able to run the entire workload on GPUs, or even saying just a subset of GPUs, or specific sections of the code to use GPU and others CPU that you know are maximized to work on the GPU. We also introduced a feature called shared RDD way back before data frames came out, where you could actually submit an application that generates all your RDDs and submit other applications to it to reuse those RDDs. This way you didn't have to keep recomputing those RDDs over and over. And then we also had additional features. I'm not going to list them all out, but we also extended features like SSL to really give full secure SSL across the entire product. So what does it mean when we started to change all the Spark code? So in the very beginning, when we started to do all these new features, adding a new cluster manager, we started changing 150 plus Spark source files to some degree. Some were really small, some were really big. Some were just, oh, we need to use this class now instead of another class. So instead of casting it from one class, we changed the casting to another. So the logic didn't really change, but we still had to make changes to those source files. So in the early days of Spark, we kept shipping lots of new versions of Spark very quickly. So this was a pain. So we had to go through 5 steps every time we had a new release. We had to change the code on open source Spark, and then we had to change the code in our newly added files, build it all together, and then do full regression testing. And then additional QA verification on top of that for all of our features that we've added. You can only imagine how painful that was for us every time a new release came out. We spent a lot of time on that. We wanted to make sure we had new versions of Spark coming out just as quickly as the open source was shipping them, because that's what customers were expecting and wanting. So we started thinking, how can we make this better? What can we do? We needed to reduce that dev effort in those first few stages, and then that QA effort. We can't keep doing that full regression testing and additional QA and all that dev work. So how can we shorten this without changing open source? So to do that, in the beginning, what we did, let me first introduce a concept, actually. And within the Spark master, all the logic that does our scheduling is something we call the session scheduler. And it's a concept that we've used throughout various products and that Ego belongs to, and that we'll look at for other workloads. So with that, we thought, okay, all of that session scheduler logic is pretty much stable from every Spark release to the next. It's not really changing the Spark code too much. It's using some of it. So what if we were able to decouple that with a couple of code changes into a totally separate scheduler, into a separate module? And with that, we'd make it specific for one Spark version, because like I said, we're really using very common open APIs within Spark here that have been around for a long time. So what we did, we settled on using Spark 2.1.0 for this decoupled stable branch that we used. and put all the code for Session Scheduler into it. This is why we would only have to upgrade the other parts that we really hook into tightly, like the work we did for GPUs. That's very much integrated into Spark, so we'd always have to change for that. So here's a picture of all the code that we started to change to some extent. So the green shows things that are completely new and added by IBM Spectrum Conductor. The red starts to show the pieces that we've changed, and the larger the box, the more we've changed it. So you can see some of them here, we've done a lot of code changes to, while the others, we haven't changed too much. So here, if we go through it, we have the Spark driver on the left. In here, we changed the GUI code a bit because we added additional fields to tables and whatnot to show specific ego concepts in them. We added our GPU RDD support in it. We added security. And we made changes to the shuffle service and the Spark context. On top of that, we added our scheduler backend. So different from the other schedulers as part of Spark, we actually have part of our scheduler backend in the Spark driver. So then within Spark Submit, the client got changed a little bit because we have our own Spark parameters. So we need to be able to show those and list those out as you're using Spark Submit. Below Spark Submit here, you can see a whole new box that's green for the application service. So the application service is a new concept that really should be in the Spark master, but it goes side by side with the Spark master for handling the knowledge about all the applications that are running within that Spark master. So it has the full history with the REST APIs. It doesn't go to the full extent of the history server, of storing all the event logs and everything, but it keeps a high-level view of all the applications and has REST APIs to integrate and get all those details, which you can get through the Spark Master UI and the internal REST APIs that it has. So then we have the Spark Master, or as we will call it, the session scheduler part of the Spark Master here as well. So we have the GUI, which we changed, just like the driver, because we have some additional fields for ego. We've changed the security for the SSL. We've changed the master logic within the Spark Master, the key components there. And as we can see here, we've also changed the protocol for how the Spark driver and the master communicate, and then now communicate through the scheduler backend. And then in addition to this, we have the REST APIs and persists, how we persist things. So those are the ones that we've changed. What we've added here is policies. So we have additional policies for how you do scheduling. We have first in, first out, fair share, hierarchical policies, and some more. On top of that, we've done some delegator changes and our specific ego resource allocator changes in there. So you're starting to see a picture that there's a fair amount of things changed here. And then in the history server, again, just like before, we had to update the GUIs, more security, and the login system. We introduced a login system to all the GUIs. And for the Spark executors, we changed and introduced the ego backend for the communication. So with all of this, we wanted to simplify it. So it was 150 plus files that we were changing. Over time, we got better at it, right? We were just doing proof of concepts in the beginning, so it really wasn't 150 plus files that got changed all the time. And it went down from there a little bit, but we were still changing a lot of files for the scheduler logic here. So the big part that we wanted to try and decouple is this whole middle part here. This is the part that we believe we can take and decouple out nicely to make our efforts for development and QA much simpler. So how did we do this? So we moved all of that session scheduler logic into another file. This is about 60 files. So what we did was we took all that code, moved it from from another folder, Spark version core, and moved it into another common folder for the session scheduler. And we packaged it up into another jar. So this handled having all of that separated. But then how do we actually get that into our Spark package that we ship? So to do that, what we did was we decoupled the session scheduler from the Spark core version, especially the RPC part, and it was built in a shaded Spark core. So we used the Maven shading to actually shade the logic here. So the shaded Spark core was renamed from the package that we had from the previous step, org Apache Spark session scheduler, which was originally before we created and moved it out, org.apache.spark. And then we had to do the shading, so that when we built it, org.apache.spark.session scheduler got shaded to be under org.apache.spark. And this won't interfere with other Spark. So in the end, it wasn't just one jar that we actually had to build. We built a couple to break it down a bit better. So what we had here was the main jar file, the Spark core with session scheduler logic, which we had called ss-spark-core. But then it had a couple of dependencies that we wanted to break down. So we had dependencies for the Spark launcher, the Spark network common, the network shuffle, tags, and Spark unsafe. So just to make our lives easier, we broke it down into all these pieces, keeping the original Spark core, Spark launcher, and network shuffle jars that you see above there, and handled this all through shading. So here's a picture of how it works. So at the top here, you can see that we have our Spark core on Ego, 2.1.0 jar. Everything's in it. But after doing the shading, we have our different packages. So on the left is all of our open source. Everything's org Apache Spark deploy in this part of the example. And on the right, it's org Apache Spark session scheduler deploy. And from here, you can actually see that the different pieces that we shade are coming from our session scheduler jars now, and shading it into the original jars when it all gets loaded. So, was this perfect? No. This improved our time to ship additional Spark packages by a lot, but we still had a lot of work to do with it. We were still modifying Spark code through shaded jars. And in the end, it didn't last us that many releases before we actually started maintaining more than one copy of the session scheduler codebase. So when Spark updated Scala /Netty in Spark 2.3.0, it required us to now have two different versions. We couldn't build the new session scheduler for the new Spark versions and maintain the old ones with the same code base. So then we started to have two different versions of the session scheduler logic. Usually we were only updating the new one, but for 2.2.1 or older versions that we were still releasing fixes for, we still had to keep updating the older one. So we had two different versions going on throughout this. So this still had a lot of pains. So what could we do next, really? There's not too much more that we could do just ourselves. And really, we should be working with the community to make this better. So what can we do working with the community to improve this, not just for ourselves, but for others out there? There are other cluster managers from other enterprise customers. And then the Spark scheduler forked the code base for a while, did its work there, and then brought it in, because it couldn't be fully pluggable. It still had to bring it into Spark. So how could we make this pluggable so even something like Kubernetes could really handle being pluggable in here and shipping on its own and not having to be part of Spark and forking the code base. So the proposal we have today is something we're still working on, and we'll look for feedback from the community, and if you're interested in helping out with this because you want to plug in other schedulers out there, let me know. What we want to do is have a true pluggable scheduler for all resource managers. Treat each resource manager as a separate plugin. We don't need to have Yarn, Mesos, Spark Standalone, all part of the main package that can be separated, worked on separately, especially Kubernetes. It shouldn't have to be tied to the releases of Spark. It's being built a lot and constantly changing. The one exception to this is the Spark Standalone scheduler. It can always ship with Spark. It's always built to be the standalone testing scheduler that you use. So that should be there. And a lot of the other resource managers actually use code from Spark Standalone. So it should be the base that all the other resource managers' plugins reuse. So each resource manager can then ship its own jar file, or multiple jar files, depending on how they want to break it up, with its classes either extending or overwriting the Spark Standalone scheduling. So how do we do this? So we can build all of our code separately into new classes with new jar files. But how do we make it pluggable? So what we can do is we can define a Spark configuration file that defines the plugin for the scheduler to use. It can be really simple to having a whole list of the different classes that you want to override. Now, the list of classes that we want to make overridable within Spark is something that we need to discuss as a community, which ones should be, which ones shouldn't be, that we want to make sure are standard across all resource managers. So the way to do this is there's some example code here, and this is code that we actually used in our decoupled solution for various parts. Within open source Spark, what we can do for these classes that we believe should be overridable is in that configuration file where we have the list of classes that we want to use instead of the base standalone one, we have the name of it for it. So in here we have the bold part, which is what would come from a configuration file. And we'd reuse the standalone one if the configuration file isn't here. And what we're doing is just some simple class.forName that we want to load the different class for. And then we'll use that class, get the constructor for the type of object class that we want to do. In this case, it's Spark context. And then we create a new constructor of it as the instance of the class that we want here. So in our case, task scheduler implementation, we usually override that, and it's usually contained in our ego deploy scheduler here. So with this, if we continue to take this concept throughout the open source Spark code, we can really make it truly pluggable. Because now we're just pulling in the correct class file that we want to override and use. And we don't have to do this for every single class, because we'll determine the list of the ones we want to override and only have those overridable, and use the Spark standalone ones in all the other cases, which is what we usually do for all the other Yarn, Mesos, Kubernetes today anyways. So that's the proposal we have. We're still working to get the Jira open for it, but we're looking for feedback from the community on how we can work to improve this even more and make it pluggable to make sure it's good for Kubernetes, our own ego, and other enterprise resource managers out there today.
All right, any questions? Anyone? Okay then, yeah, that was the last session. Thank you so much for attending. Have a good evening.
Question over there?
Oh, sorry.
So what's keeping you from opening a Jira? That doesn't make sense to me.
From what's stopping us from opening a JIRA?
Yeah.
No, nothing's stopping us. We want to have that list of classes first
Okay.
and have that in the JIRA. We don't want to have a JIRA that just says this idea. We want to have a little bit more details in it. So we're going to open up that JIRA soon.
Okay. I encourage you to open it first and fill it in later, but that's just me. You can get feedback on the idea sooner if you do that.
Sounds good.
Okay.
Thank
Cool.
you.
Good luck.
Thanks.